Hey everyone, and welcome. If you've got your sights on passing your WAEC, JAMB, or NECO chemistry exams, then you are in the perfect spot. Today, we're going to break down one of the trickiest topics out there, mass volume concepts, and give you the tools you need to crush any question they throw at you. Let's jump right in. Does this sound familiar? You see a question asking for the volume of gas from a certain mass of a solid, and your mind just goes blank. We've all been there, but don't worry. I promise, by the end, you'll have a crystal clear, step-by-step method to solve these problems every single time. Okay, let's get into it. First up, why are we focusing so hard on this? Well, because mastering the link between mass and volume isn't just a small part of chemistry. It's your secret weapon for a top score. This stuff is absolutely fundamental. It's the bedrock of stoichiometry. Think about it. It's how we connect something we can actually weigh on a scale to something we can't, like the volume of a gas. And this isn't just for exams. It's used out there in the real world, from industries like welding to important work like monitoring our environment. So how do we tackle these problems without breaking a sweat? I want you to think of it like building a toolkit. We're going to give you 4 essential tools that will let you take apart and solve any mass volume problem you face. Our very first tool is probably an old friend of yours, density. It's just the simple link between how much stuff, that's the mass, is packed into a certain amount of space, that's the volume. It's a key piece of our puzzle. And here's its formula. Density, that's the symbol rho, is just mass divided by volume. It looks simple, but it's incredibly powerful, and you've got to have this one locked away in your memory. All right, on to tool number 2. And honestly, this one is a total game changer for any calculation involving gases. It's called molar volume. And here's the big idea. At what we call standard temperature and pressure, or STP, 1 mole of any gas, I don't care if it's oxygen, helium, whatever, it takes up the exact same amount of space. And what is that magic number? It's 22.4 decimeters cubed. Or, if you need it in centimeters cubed, that's 22,400. This number is your golden ticket. You absolutely, positively must memorize this for your exams. It's the key that unlocks volume from moles for any gas at STP. So, how do you use it? It's unbelievably easy. You just find the number of moles of your gas and multiply it by 22.4. So if a question says you have half a mole of carbon dioxide, you just do 0.5 times 22.4, and boom, 11.2 decimeters cubed. It really is that simple. Now for our third, and you could say our most powerful tool, stoichiometry. The best way to think about this is like it's the recipe book for chemistry. A balanced equation gives us the exact ratios to figure out the volume of a gas we'll get from a certain mass of a starting material. This is the bridge that connects it all. Let's see how this works. Imagine we're breaking down 10 grams of limestone. First step, always, is convert that mass to moles. That gives us 0.1 moles. Second, we look at our recipe, the balanced equation, which tells us 1 mole of limestone gives us 1 mole of CO2. It's a 1-to-1 ratio. So we have 0.1 moles of CO2. Finally, we pull out our magic number. 0.1 moles times 22.4 gives us 2.24 decimeters cubed of gas. See that? Mass to volume in 3 easy steps. Okay, our final tool is a really handy shortcut that you'll sometimes see pop up in questions. It's called vapor density. All it is a simple way to figure out the molar mass of some unknown gas by comparing how dense it is to hydrogen, which is the lightest gas of all. And the formula could not be easier. The molar mass is just the vapor density times 2. So why 2? Because we're comparing it to hydrogen gas, which is H2, and its molar mass is about 2. It's a super quick and easy conversion to remember. All right, our toolkit is officially built. You've got density, molar volume, stoichiometry, and vapor density. Now for the really fun part. Let's put these tools to work on real, actual past exam questions. Here's a classic from a WAEC paper. We're given a mass of sodium nitrate, and they want to know the volume of oxygen gas we get when it's heated. This looks like a perfect job for our stoichiometry tool. So we just follow our steps. First, get the mass into moles. 8.5 grams divided by the molar mass, 85, gives us exactly 0.1 moles. Now, and this is crucial, we look at our balanced equation. The ratio says the ratio is 2 to 1. For every 2 moles of sodium nitrate, we only get 1 mole of oxygen. So we have to cut our moles in half, giving us 0.05 moles of oxygen. Finally, we use our magic number. 0.05 times 22.4 gets us 1.12 decimeters cubed. Done. And right there is the number one trap that students fall into. They find the first number of moles and get so excited they jump straight to multiplying by 22.4. You cannot do that. You have to use the mole ratio from your balanced equation first. Never, ever skip that step. Let's try another one. This time it's from JAMB. Here, they give us amounts for 2 different reactants. Now, this question is specifically designed to catch you with a different kind of common mistake. Okay, first things first, we need a balanced equation. Then, because we have amounts for both reactants, we have to stop and figure out which one is going to run out first. We call that the limiting reactant. In this problem, it turns out to be the calcium carbonate. So that's what controls how much product we can make, which is 0.0075 moles of CO2. From there, we just multiply by 22,400 to get our answer, in centimeters cubed, which is 168. And that is the second major trap. When an exam question gives you amounts for 2 or more reactants, you can't just pick one and hope for the best. You must figure out which one is the limiting reactant. The whole reaction stops when that one is gone. So it's the boss of the entire calculation. You've seen the tools, and you've seen them in action on real problems. You are almost there. Let's just wrap things up with a quick summary and a few last-minute tips to make sure you absolutely nail this on exam day. Here are your key formulas, all in one place. Your very own cheat sheet. Density, molar volume, and that vapor density conversion. Go ahead and screenshot this, write it down, burn it into your brain. These are your keys to unlocking the points. And some final advice. Always, and I mean always, start with a balanced equation. Keep a close eye on your units. Are they asking for centimeters cubed or decimeters cubed? If you're given 2 reactants, you know what to do. Find the limiting one. And a little pro tip. For a multiple choice exam like JAMB, get fast with your mental math. For WAEC and NECO, where you show your work, make sure you write down all your units to get every possible mark. So, there you have it. You have the tools, you have the strategy. To finish up, I'm leaving you with a challenge. You're given the volume and the mass of a gas at STP. Can you work backward to find its molar mass? Go ahead, pause and give it a shot. Prove to yourself that you've got this down. You can do it. For more practice questions and solutions, visit examkp.com.